So, my name is Nikolay Marin. I work for IBM. I am here to represent IBM Academy of Technology. It's a body, cross-brand, cross-country, cross-everything, body of knowledge within the corporation through which we influence the technical strategy of the company. And through that strategy, we obviously influence the market. We shape the market, we create new markets. And I'm here today to speak about cognitive computing and how it really influences the whole aspect of life and how the computing will look like tomorrow. I'd like to start with a question. Who in this room has a brain? A brain? One, I see one, two, well, three. Maybe brains, 3, 4, little bit more than half, right? I believe it's more. But we are humans because we have brain. And the way brain works, it really interacts with the outer world naturally. And the same way computers will in future. So cognitive computers will learn, they will interact, and they will naturally interact with humans, and they will very much simulate the behavior of human brains as we work today. We all started, and still do, with von Neumann's architecture of computers. So the computers have to be programmed in advance. So they have to be assembled, built, and programmed. So they have to have a special script, some rules through which they work with data and produce results. Cognitive computing is really different. It's very much like humans do. So they normally sense, they interfere, and they predict the future through their algorithms which are not really built. They build algorithms themselves. They think. They aren't programmed. So there's no program for cognitive computing. This said, to educate cognitive computers, we use artificial intelligence. And IBM is not the only one who does it, but we believe we are quite advanced in this. With the enormous growth of data, and you all know that roughly 80–90% of data which we have today was created in the last 2 years. And the majority, up to 80% of data that computers now work with, it's dark data. So computer knows that data exists, it knows where it is, but it cannot understand. I mean images, I mean audio recordings, I mean data from sensors and various actuators. So the most of data is blind to the computer. So computers which are cognitive, they get to build the knowledge, so they develop themselves through working. It's opposite to common computers that we use today. Normally computers become outdated and they work less and less efficient as we use them. Cognitive computers become better and better every day themselves. And through that, we just take the data, we educate the computer, and through this education, we get the process data. This is how cognitive computer is working. So let's be a little bit more pragmatic. Why should we speak about cognitive computer? First, because they will really interact with humans differently through normal voice recognition, through understanding how we ask questions, and they, most importantly, will enlighten humans. I mean, they will suggest some ideas. So today's computers do a very hard job. For instance, airlines, banking, telco, they all rely on normal von Neumann's architecture of computing. And new computers will do it a little bit differently. For instance, we've started with healthcare. And healthcare is a very tough subject. It's very difficult to understand first really the diagnosis and then to suggest the treatment, the proper treatment for a human, for any disease. And we really used, and it's a real story, cognitive computer called Watson to help those who had to get treatment from cancer get the proper one. Other purposes like cities, those who follow me on Twitter and other social networks, they know I'm quite passionate about smarter cities, and one of smarter cities is being created here in St. Petersburg. A lot can be done in terms of making the city systems more efficient, but still current computing approach is struggling to support humans with this. With cognitive computing, we can predict and we can envision future, for instance, disasters and normal blocks like traffic jams, etc., just by having the data that we have and analyzing them properly. You probably heard about IBM's strategy Smarter Planet, and it's not just a marketing logo. It's not just a motto. It's really a strategy. Who's on Facebook? Who's on Facebook? Do you? Okay, more people than have brain, they are on Facebook. And do you know that when you do a real-time chat on Facebook, the message which is being sent from one peer to another is being sent through MQTT protocol. And it's a protocol which was invented by a friend of mine, a distinguished engineer of IBM and the Stanford Clark. And because the protocol was so good, we donated this to open source community. And when Facebook made the decision to which protocol to switch their real-time chat system, they have chosen MQTT because it was open source, it was very well documented, very reliable, and very tiny in terms of, very efficient in terms of infrastructure usage. So that's one of the parts of the strategy. Who plays computer games? PlayStation, Nintendo? Well, less volume than Facebook, but still chips which used to be in every game console 2 years ago. It was a cell chip, IBM Power PC chip, which was on Mac desktop computers. Then it was delivered to gaming technology with sub-chips which supported the graphical acceleration. So it was again a part of the strategy. We simply switched from solving infrastructure problems to IT problems, but more importantly to the real-world problems. And that's partly why Mr. Warren Buffett now owns roughly 13 billion of IBM. I mean, it's in terms of US dollars. So he really owns a share in companies which do some real work, and he decided to buy a significant share of IBM. And this was a strategy of IBM to build a smarter planet. It was instrumented, interconnected, intelligent, and therefore smart. Now we are moving even further. We are really moving to cognitive computing. And cognitive computing applied to business. Currently, nowadays, all the businesses are digitized. I mean, again, banking, telcos, healthcare, everything is digital. But when everyone is digital, what's differentiating? I mean, we all became e-learning, e-business, e-something. So what's the differentiator then? The differentiator then is how we really use the power of computing in terms of cognitive approach, what we have already, to become more advanced against the competition. We started with building a question and answering machine. And we tested this after chess game with a TV game called Jeopardy. Russian analog is Своя игра, when every participant of the game responds to a question. A question is being asked on a natural English language, and normally you have roughly 3 seconds to give a proper answer. And the machine which we built was disconnected from internet. It was completely self-sufficient. And the machine won against 2 major champions of Jeopardy worldwide, I mean, English language, but still worldwide champions, which were unbeaten for many years before. The machine won against them in this normal human game. I can imagine that Watson machine can win against Wasserman, who was a champion of Своя игра for a long time in Russia, as soon as we teach Russian language to the machine. So it started as a machine, and we really built a dedicated brand like IBM Mainframes. Now we have a brand called Watson, because it's a whole set of solutions and whole set of systems. So we started with a question and answering machine, but then we decided, why don't we apply it to a broader broader scope of problems? And we thought maybe we take something very low level, very human. Why don't we ask Watson to invent a recipe to cook food? And we've seen through that the machine can really do creative work. It can invent recipes which fit together. I mean, pairs of components which really fit, which are healthy and very efficient in production. Can you imagine, for instance, strawberry burrito? It's something that the machine invented. Or did you know that cherry and mushrooms fit very well in terms of taste, and it very well can be consumed by a normal stomach? We really did recipes and tried this with people. Everyone is still alive, and I've tested some of them. They are simple, but you could not imagine such a combination. And we built a truck which really served the food for free to people across the world. We issued a cookbook, a book of recipes from Watson, and it's very popular in the world now. Finally, we decided to how do these systems really work? And we understand that they do not work isolated. They help with different industries like oil and gas, like telco, but we understand that the cognition is not isolated. And a good example of such is really a toy, a small plastic dinosaur which is connected to Watson computer, and it interacts with kids. Kids ask questions using natural language. It understands within the context in which room it is now, in which date in the calendar, and in which environment it is, and gives really meaningful responses. It's a toy, but it's a real one, which you can buy from Cognitoys, and the one which works in a real cognitive environment. So cognition is distributed, and we can imagine different applications of that, like cognitive car, cognitive cafe, cognitive mobile something. But what's more important is it's really can be hard-coded. We built a synapse chip. Initially, it started as a nanotechnology funded by DARPA. Have you heard about DARPA? ARPA. ARPA you've heard, yes, ARPANET, Internet, all this stuff. And this the same ARPA, which is now renamed into military ARPA. It was useless device, but we really built on top of this device a normal chip which can scale, and basically the brain for a human can be built as a chip, as one single chip. Finally, it has synapses, neurons, axons, so it's a chip which is very energy efficient, and we hope to build a 10 billion neurons, 1 trillion synapses chip, a brain on one crystal. And we succeeded. The one we issued last year already has 1 million neurons, and it really evolves. You might ask, what's in it for me? And this cognition is really available today. First, it's an application for doctors, for medical doctors on iPad who want to help those who suffer from cancer. They suggest a proper treatment. It analyzes the data. Just to read all the publishings made today about cancer, you have to spend 5 hours, and the volume of publications doubles every year. But it suggests a real treatment based on what you have in your medical record and what are the solutions provided. And also, the doctor makes the final decision. But you can use the same technology for your business. For instance, if you go to Watson Analytics, it's all about speed. I mean, you can load your data, and the machine will define the correlations between different data sets for you automatically. It's not available for free. You can go to Watson Analytics Google this name and find the system. We don't ask for credit card. We ask actually for nothing. You can log in and play with this solution. It's very non-IBM type of interface like this one, very much like Apple application. And with the data, it visualizes and also finds the correlations and visualizes these correlations. But that's not only. How the oncology application actually works. It analyzes the patient's medical record. It does the research based on history and all the publishings. And finally, it suggests the treatment with ranks, with potential probability of success, and also gives the explanation and provides some description from where does this treatment come. So it really helps the doctor, but he makes the final decision. The same way can be applied to any type of industry. We are in financing market, and you probably seen these 20 cognitive biases that screw your decisions. Like we tend to anchor to the first data set that we get, or we don't think that more data will come and we stick to that. You can Google, I've given the link, by the way, and the slides will be shared, so you can find this. But humans are quite tied to patterns that they used in the past. And with these patterns, we become stressed and pressed. We do not become innovative. And this is what applies, for instance, for trading. Traders, they sell to investors services which are actually based on beta. I mean, simple guessing. We guess if it will go up or down. We do not often get the service which is based on real decision making and the data analysis. What a small startup called Alpha Modus created, they really analyzed the shouts, they recognized the voice from trades on New York Stock Exchange, on a trading floor, the real ones. The traders were shouting and found imbalance between buy and sell puts, trying to predict how the market will close. The last 2 seconds, when the market closes, they predicted the imbalance, to which direction it will turn. And based on this voice recognition, analysis of data, they really sell the service. You can buy this. I can go and buy this to normal humans. You can put your money and bets on this, but this is really based on data analysis. Who has a computer at home connected to internet? Well, the majority. Right today, you can go to your browser, type Bluemix there, and it's IBM Cloud. It's now free of charge. You can log in there, get the service, and get the same cognitive services as an API, as a developer, as an API. You can use them and put them into your application. Maybe build a small dinosaur, maybe build a new trading application, maybe start a company, maybe improve your company's service. With that, I would like to thank you and turn over to your questions. I see 2 questions there.
How do you think about the prediction by Elon Musk and Stephen Hawking recently? They have made recently about dangers of
artificial
intelligence.
Yes,
yeah,
exactly. That's why we are talking about cognitive. Artificial intelligence we use, but to educate the machine. The machine is just an advisor to a human. It does not make the final decision like a doctor. The doctor makes the final decision about treatment. But the machine suggests the treatment. And that's exactly the approach of cognitive computer. Like plastic dinosaur, it does not make a decision. It interacts with you, it can suggest, but will never give this thing to make the final decision. That's cognitive.
Practical question. Can this thing trade?
It can.
Profitable?
It depends on how you use the advice.
Well, actually, as far as probably everybody knows, there is no thing that can predict market movement, really.
Exactly. Predictions are only built to make the predictors good. That's what Warren Buffett is saying about this. And it's not the idea to predict the market. The idea is to predict maybe the behavior and maybe get the probability of success of whatever activity. That's cognitive. We do not
Exactly.
make predictions
So
just...
what is your percentage of good prediction?
The machine actually gives you a percentage of success. This is how it worked with Jeopardy game, and still it does. I mean, it never goes beyond, I would say, 80%. And you have to make decisions. If the first option is 80% and the second is 79%, you make the decision. But it always depends on the volume of data and the time you spend on educating it, as well as the right context. The good notion is word now. Whatever language you use, сейчас in Russian. Now, if you read a book which speaks about the past, it's 2,000 years ago, but it's still now there. Now it's this day. Now it's this millisecond. It's very context dependent. And that's the term which is most hard for educating the machine. And that's where the human must make the final decision. And now is very much specific for trading and markets.
Can you please share some underlying technologies which you use here and resources of Watson, which use Watson to do his predictions on cancer to advise doctors?
Well, when the machine played the Jeopardy game, it used, for instance, 6 megawatts of power. It was really a big one. The whole room with power CPU-based machines. Now it's available as a cloud and it's distributed. It's available as a cloud service. So it's hard to estimate how much resource does any request take. But it's basically built on good old technology with with significant novelty put on top of this. For instance, we use SPSS software product, which was very well known on the market in the past. SPSS was used for cluster analysis in statistics. We use power chips. We use fast data storage like flash technology, which we successfully sell to banks across the globe and in St. Peter as well. We use many proven technologies, but the novelty is first the approach and the algorithm of educating the machine.
Thank you.
Thank you.
Thank you.
Actually, while we are changing slides, we do try, one of our work groups tried to use IBM Watson and sentiment analysis for predicting the closing price for the next day. So they claim that they took end of day data like closing prices, volumes, etc., and they also took sentiment analysis of the tweets related to particular instrument. And they claim that their result is they are able to predict with 80% probability whether it will go up or whether it will go down. We are saying that they are not capable of properly testing their software. And I think academic research that is now available shows something like 55–60% of predicting whether it will go up or will go down. Thank you.